This is a stress life example. Let's look at the problem statement. A component undergoes axial loading, cyclic loading, as summarized in the table below, which was obtained from rainfall counting. Now you all know about the rainfall counting procedure and how we take the stress signal and pass it to a rainfall counter to get the stress amplitudes and means or stress ranges and the associated number of cycles. Now here we can see stress amplitude, sigma A in MPa, with stress mean, sigma mean, also in MPa, and then the number of cycles per repetition. Now this was for one repetition. So it was 100 with a 200 mean, there's 100 with 100 mean, and 200 with a minus 100 MPa mean, and the associated number of cycles. Let's read further. The material is steel with ultimate tensile strength 1050 MPa, with hardness 300 Bernal, and the theoretical stress concentration factor at the notch on the part is Kt equal to 2, so we need to drop the SN curve to model the effect of that stress concentration factor. The notch radius is R4 millimeter. Surface finish is machined, and the shaft has a radius of 100 millimeter and operates at temperature T 200 degrees Celsius. How many blocks of loading or repetitions of loading can be loaded on the component for a 1% probability of fatigue crack initiation? That means now that 1% probability of crack initiation also implies a 99% probability of survival. So what they want to know is what is the fatigue life of the component for a probability of survival of 99%. It's equivalent. So that's a problem statement. Let's do the solution. So I'm going to go there and insert heading 2. Now, our first step in this problem is we need to calculate the new SN curve for this material. Now, in this case, they don't give us coefficients for this material. They just give us the ultimate tensile strength. Now, we can estimate the SN curve, as we said, by looking at the endurance limit, the fatigue strength at 1,000 cycles and the endurance limit at 1 million cycles, and then calculate the slope. Remember, we need to make modifications for the fact that we have a notch on this specimen. So our first step in this case, you can start with your factors as well, but our first step in this case, let's see what the formula sheet says in terms of the influencing factors that we need to look at. Let's open the formula sheet. The formula sheet is there. Now, if we look at the formula sheet, to calculate our endurance limit, we need to look at the following factors in the curve. Here we can say the modifying factors. They are for size, for load, for surface, temperature, and reliability. That's to calculate the endurance limit. Then we have the one at 10,000 cycles, which is load, temperature, and reliability. Now this formula sheet will be with you, so you know where this comes from. Now please note that when you calculate this, we use the strength, the bending fatigue strength of the material in this formula. So that's why you see the accent there, and this is down the endurance limit for our problem that we want to solve. And as you can remember, the endurance limit here is ultimate tensile strength times 0.5. That's one estimate, but we'll go through that whole process now. So that's our problem statement. I'm going to save now so that we can continue from here.